Find the volume of the solid obtained by rotating about the y-axis, the region bounded by y equals e to the negative x squared, the line y equals 0, the line x equals 0, and the line x equals 1. Keep in mind that when we draw the graph of the region, the x and the y-axis are only help lines. They are not part of the bounded region unless they are specified in the problem. In this case, they are included because the line y equals 0 is the x-axis. The line x equals 0 is the y-axis. The line x equals 1 and the curve y equals e to the negative x squared. The bounded region is this region. We take this region and rotate it about the y-axis. Using the shell method, we will slice the cross-section parallel to the axis of rotation. And so we end up with a representative shell. The volume of this shell, V sub I, is therefore 2 pi times the radius times the height times the thickness, but since we slice it parallel to the y-axis, meaning we slice it perpendicular to the x-axis, the thickness is delta x. Because of the delta x, we need to express r in terms of x and h in terms of x. Where we slice the solids, we would label the point x, y. The radius is therefore x in this case, and so we have r equals x. The height is the value of the function, and in this case, it is the function y equals e to the negative x squared, and so the h is f of x, or e to the negative x squared. This is the ith slice or the ith shell only, so this is x sub I, x sub I. The volume is 2 pi times xi times e to the negative xi squared times delta x, and this is the volume of one shell only. The total volume is the sum of all of these volumes of all of these shells from I equals 1 to n. There are n shells in this case. Each of the shell Vi has the volume 2 pi xi e to the negative xi squared delta x. As n goes to infinity, these Riemann sums give us the definite integral, and the slices only lie between x equals 0 and x equals 1. So the lower limit of integration is 0, x equals 0, and the upper limit of integration is 1, x equals 1. 2 pi x e to the negative x squared dx. But 2 pi is a constant, so we can move it to the front of the definite integral. The integrand is 2 pi x e to the negative x squared dx. We now use the fundamental theorem of calculus to evaluate this definite integral. We can use u substitution, where we let u be negative x squared. Du is therefore negative 2x dx, so that x dx is negative 1/2 du. Also, when x equals 0, u is negative 0 squared, or 0. When x equals 1, u is negative 1 squared, or negative 1. X dx can be substituted with negative 1/2 du and e to the negative x squared, where negative x squared is now u. Simplifying this, we have negative pi, the integral from 0 to negative 1, e to the u du. But because of the negative in front of the integral, we can change it to the positive integral by switching the limits of integration. The upper limit becomes the lower limit, and the lower limit becomes the upper limit. The antiderivative of e to the u is simply e to the u, so we obtain pi e to the u and evaluate at negative 1 and 0. Plug in 0, we have pi e to the 0. Plug in negative 1, we have pi e to the negative 1. So the exact volume is pi times the quantity 1 minus 1 over e.